Chapter 6, Part 3, page 226, Guidelines for Core Training. A comprehensive core training program should be systematic, progressive, functional, and emphasize the entire muscle action spectrum, focusing on force production, concentric contractions, force reduction, eccentric contraction, slowing it down, and dynamic stabilization, isometric contractions. Core training exercise variables. Exercise selection should be progressive, easy to hard, simple to complex, known to unknown, stable to unstable, systematic, stabilization, strength, power, activity goal specific, integrated, proprioceptively challenging, stability ball, floor, half foam roll, foam pad, wobble board, based in current science. The variables: plane of motion, sagittal, frontal, transverse. Range of motion, full, partial, end range. Type of resistance, stability ball, cable. Type of resistance, stability ball, cable. Tubing, medicine ball, power ball, dumbbells, other. Body position, supine, prone, side lying, kneeling, half kneeling, standing, staggered stance, single leg, standing progression on unstable surface. Speed of motion, stabilization, strength, power. Speed of motion, stabilization, strength, and power. Duration, frequency, amount of feedback, fitness professional cues, kinesthetic awareness. The core training program regularly manipulates plane of motion, range of motion, modalities, tubing, suspension trainer, medicine ball, kettlebells, foam pad. The core training program regularly manipulates plane of motion, range of motion, and modalities, tubing, suspension trainer, medicine ball, kettlebells, foam pad, etc. Body position, amount of control, speed of execution, amount of feedback, and specific acute variables. For example, sets, reps, intensity, tempo, and frequency. When designing a core training program, the sports performance professional should create a proprioceptively enriched training environment, selecting the appropriate exercise to elicit a maximal training response. Core exercises performed in an unstable environment have been demonstrated to increase activation of the local and global stabilization systems when compared to traditional trunk exercises. The core exercises must be safe, challenging, stress multiple planes of motion, and take place in multi-sensory environment derived from fundamental movement skills specific to the activity. The goal of core training. Core training program, page 227. The goal of core training is to develop optimum levels of neuromuscular efficiency, stability, intervertebral, intersegmental stability, local and global system, and lumbopelvic stability, and functional strength, movement system. Neural adaptations become the focus of the program instead of striving for absolute strength gains. Increasing proprioceptive demands by employing a multisensory environment in multiple modalities, balls, bands, balance, equipment, becomes more important than increasing the external resistance. Quality of movement is stressed over quantity. The focus of the program must be on function. The following is an example of integrated core training programs. The athlete begins at the highest level at which he or she is able to maintain stability and optimal neuromuscular control. The athlete progresses through the program once mastery of the exercises in the previous level has been achieved while demonstrating intervertebral stability and lumbopelvic stability. For example, an athlete has appropriate intervertebral stability when able to maintain a drawing in position while performing the exercises, ball, bands, unstable equipment. The athlete has appropriate lumbopelvic stability when able to perform functional movement. Functional strength. Functional strength. The ability of the neuromuscular system to produce dynamic multiplanar, eccentric, concentric, and isometric stabilization actions quickly and efficiently during functional movements. Pro tip. A sports performance program focused solely on development of the core will not translate to increased performance. Building a strong and stable core, in addition to strengthening the rest of the body, will improve overall athletic performance. Start with the core. For example, the athlete has appropriate lumbopelvic stability when able to perform functional movement. Page 228 patterns. Functional movement patterns. Squat, lunge, step up, single leg movements, pressing, pushing, etc. Number 1, intervertebral stability. Number 2, lumbopelvic stability. And number 3, mobile movement efficiency. Core stabilization exercises. Core stabilization exercises. Exercises that involve little to no motion through the spine and pelvis. Core stabilization exercises. To improve core stabilization, exercises involve little to no motion through the spine and pelvis. These exercises are designed to improve neuromuscular efficiency and intervertebral stability by focusing on the local stabilization system. The athlete should spend 4 weeks at this level of core training. Core stabilization training program. The goal of core stabilization training program is intervertebral stabilization and neuromuscular control, focusing on drawing in and then bracing during these exercises. So drawing in maneuver progression, supine, supine with march, supine with heel slide, supine with both knees to chest, supine with 2-leg slide. Iso-abdominal series, prone, prone with hip extension, prone with abduction away, side with hip abduction, so pro side, so side plank, side with shoulder abduction, so opening up. Prone progression, floor cobra, prone arm and opposite leg raise, Superman. Supine progression, 2-leg floor bridge with march, floor bridge with knee extension. Quadruped progression. Okay. Arm raise, arm and opposite leg raise. Core strength exercises. In core strength training, the exercise involves more dynamic eccentric and concentric movements of the spine through a full range of motion while your athlete performs the neuromechanical activation techniques learned in core stabilization, drawing in, and bracing. The specificity, speed, and neural demands are also progressed in this level. The athlete should traditionally spend 4 weeks at this level of core training. These exercises are designed to improve lumbopelvic hip stability, eccentric strength, and neuromuscular efficiency of the entire core. Goal of the core strength training program. These exercises are designed to improve lumbopelvic hip stability, eccentric strength, and neuromuscular efficiency of the core. Core strength, exercises that involve more dynamic eccentric and concentric movements of the spine through a full range of motion, while the athlete performs the neuromechanical activation techniques learned in the core stabilization. Drawing in. That's what they learn. In core power training exercises are designed to improve the rate of force production by the core musculature. These forms of exercise prepare an athlete to stabilize and to generate force dynamically at more functional, applicable speeds. It is imperative that athletes have the appropriate intervertebral stability and lumbopelvic hip stability prior to progressing to this phase of core training. These exercises are designed to improve rate of force production by the core musculature. So, medicine ball exercises, rotation chest pass. A1, B1, B1, front oblique throw. C, wood chop throw. D, overhead throw. A lot of throwing, explosive movements. Overhead throw with rotation. Side oblique throw. Soccer throw. Core training program design parameters. Implementing a core training program requires that sports performance professionals follow the progression of the OPT model. For example, if an athlete is in the stabilization level of training, phase 1, select core stabilization exercises. Once the athlete progresses to the strength level of training, the sports performance professional should select core strength exercises. For an athlete who has progressed to the power level of training, phases 5 and 6, select